Welcome. In today's video, we'll look at a few rules that govern trigonometric substitution when dealing with integrals. The first rule that we'll look at is when the integrand involves an expression of the form square root of a squared minus x squared. And what the rule tells us is that when we have that case, we can use the substitution of x is equal to a sine theta. And the way this works out is when you do that substitution, then you have the square roots of a squared minus a sine theta squared all under the square root sign, right? Let's make some room here. Right, so we're saying what happens is that when we have this trigonometric substitution, that is equal to the square root of a squared minus a sine theta squared, and that just gives us the square root of a squared minus a squared sine squared theta. Again, all under the square root sign. We can clearly see that a is a common factor there, so we can pull it out. Then we have the square roots of a squared multiplied into 1 minus sine squared of theta. Again, this is all under the square root sign. Then obviously, since we have a squared there, that can come out of the square root sign, and we have a multiplied by the square roots of 1 minus sine squared of theta. And from our trigonometric identities, we remember that sine squared plus cos squared is equal to 1, so cos squared is just equal to 1 minus sine squared, so we can replace this whole thing by cos squared of theta, and that is just equal therefore to a times cos of theta. So that is what ends up happening. And then when we have this form, we can easily do the integration of a form such as this one, right? So the second rule looks at, just give me some room here. So the second rule looks at the case where the integrand contains when the integrand contains the form square root of a squared plus x squared, and in that case we're told that we can use the substitution of x is equal to a tan theta. Right, so let's see how that works out. So if we use that substitution, we have the square root of a squared plus a tan theta all squared, again under the square root sign, which gives us the square root of a squared plus a squared tan squared theta, right? And this is just equal to the square root of, again, a is a common factor there, we have a squared multiplied into 1 plus tan squared of theta, and this is just equal to a, right, that comes out of the square root sign multiplied by the square roots of 1 plus tan squared of theta, right? Now, once again, if we go back to our trigonometric identities, we know that 1 plus tan squared of theta is just equal to sec squared of theta, So we have a multiplied by the square root of sec squared of theta, which is just equal to a multiplied by sec theta, right? Which we can also easily integrate. And yeah, so then the next basic rule that we'll be looking at is the case where we have under the integrand the form of the square root of x squared minus a squared. Now in that case, the rule tells us that we can use the substitution of x with a sec theta, right? And what happens when we do that is that we have the square root of a multiplied by sec theta all squared minus a squared, all under the square root sign, and that is just equal to the square root of a squared sec squared theta minus a squared. And this just gives us, it gives us that a is a common factor, so we can pull it out. So we have a squared multiplied into 1, or rather, sorry, not 1 but sec squared theta minus 1, right? Again, all under the square root sign, and this can be further simplified to be a multiplied into the square root of, we know from our identities that sec squared minus 1 is just tan squared, so we have a multiplied by the square root of tan squared of theta, which is just a multiplied by tan theta, which we can easily integrate using the rules that we've seen before, right? So the next rule that we'll be looking at is the one where we have the form of the square root of a minus x squared, and in that case we can use the substitution of x with a sine theta. And what happens when you do that is that you have then the square root of a squared minus a sine theta squared, which is equal to, once again, a squared is a common factor, so we can pull it out. We have a squared multiplied into 1 minus sine squared theta, and that is just equal to the square root of, again, a can come out of the square root sign, so we have a multiplied by the square root of 1 minus sine squared, which is just cos squared, again from our identities, and that is just equal to a times cos of theta, right? So these are all the basic rules that we'll look at for now, and there's 4 of them. So basically we'll try to look at a few examples next, dealing with cases where we have these types of integrals, and we'll see if we understand the concept, right? So stay tuned for the next video dealing with some examples. Thank you.